Hello. In this video, we're going to look at the opposite problem from last time. How many arrangements of the word cat are there if the letters A and T must never be together? So instead of having A and T always together, now we have A and T never together. Well, again, like normal, if we don't know what we're doing and we don't have a formula, it's always a good idea to write out all of our options. So that might look like ACT or TCA, and I think that's it. So the answer here is going to be 2. Now, I don't know how you go from 3 factorial, which is 6, down to 2. I'm not sure how the formula would work. This seems really weird. So let's try a larger question to see if we can get a hang of it. How many arrangements of the letters in the word France are there if the letters A and E must never be together? Now remember, for France, it would be 6 factorial, which is 720. So the number should be less than 720, some kind of modification on like 6 blanks. But how do we do this? Well, again, we could look at all the different cases. So just like before, we'd have 6 letters, but we want A and E to not touch. So for example, you could have A here and E here. You could have the case where maybe A is here and E is over here. So I'd encourage you to pause the video and see what you come up with. How many different cases can you find with A and E not touching? All right, so assuming you gave it a try, let's keep writing out all the different cases. We could have A and then E here. And then we could have A in the front and E all the way at the end. Now we could also have A in the second spot. And so then we'd have E here. We could have A here and E over here. A here and E at the end. Again, let me just write out the blank so we can see. Something like that. Now let's keep moving on with that A. Maybe we'll draw some more blanks here just so we can position those letters. So A here, E here, A here, E over here. And then we got one more A here and E here. That's going to be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now technically we could also flip E and A. So for each one of these, I think when we're starting it off, we're sort of saying A or E at the beginning and then the other letter over here. Because we don't want to like redo all this work with E first and then A in the third position. That's just too much. So we'll write this as 2 options, then 1 option. 4, 3, 2, 1. And that's going to give us 48. Again, 2 options here, 1 option here. 4, 3, 2, 1. It's going to give us another 48. All of these are going to be 48. So if we add them up, there's going to be 10 48s. In other words, 48 times 10. So 48 times 10 is going to be 480. Now again, like before, we should probably check this on some kind of supercomputer, some kind of Excel spreadsheet, just to ensure that this is indeed the correct answer. So let's go ahead and do that. All right, so here we have all of the different combinations of the word written out. And if A and E are not together, we'll put a 1 in this column. And if A and E are together, we'll put a 0 in this column. So we can take a look here and we can see that this indeed goes down through all of the different options down to 720. And if we add up all of those options, we get a total of 480. All right, so our answer seemed to be correct, 480, but how can we do this with a formula? So we know we have F, R, A, N, C, and E. Normally, this would give us 6 factorial, which is 720. The answer we have is 480, but how do we go from 720 to 480? Now, this is a bit of a new technique here, and so if you want, you can pause the video and think about it for a little bit. All right, so what we actually do is we ask a different question. So for A and E to never be together, okay, this over here is never. Instead, why don't we look at always? We remember how to do them always together. Last class, that was going to be 6 blanks. We group 2 of them together, 2, 1, and then we draw an extra blank up here. 5, 4, 3, 2, 1. Multiply everything together, and that gives us 240. Now, obviously, by saying them all together, I've made up a new question. This isn't the actual question. But if I subtract these two numbers, 720 minus 240, I'm going to get 480, which is exactly my answer. Okay, what just happened here? Well, I took the total number of options, and I subtracted the opposite. And that gave me my answer. Let's use an analogy, okay? Let's say that there are 30 people in a classroom, okay? And let's say I'm teaching in the classroom and I tell you there's 30 people. How many of them are students? Well, if we know there's 30 people in the classroom and I'm the only teacher, we could just count all the students, right? We could go around the room and count this student and this student and this student and this student and this student. But I mean, that seems like we already know there's 30 students and there's only one teacher. So if we go 30 minus 1, we're going to get 29 students. So if there's 30 humans or 30 people in the class and one of them is a teacher, you don't have to count all 29 students to know the number 29. You can simply subtract the one teacher and get you your answer. In other words, the teacher is the opposite. You count the opposite, which, well, since there's only one teacher, it's really easy to count to 1. It's a lot easier than counting to 29. Over here, you do the always question. You make the A and E always together because that's pretty easy to do with the little box around the 2 blanks. And then you subtract the opposite from the total where you didn't have any restrictions, and that gives you your answer of 480. Let's try a quick example. How many ways can the letters in the word quest be arranged if the vowels are never together? So go ahead and pause the video and give it a try. All right, we know that there's going to be 5 factorial, which is 120. That's going to be the total ways if you had no restrictions. If the vowels are U and E, if these are always together, that's going to be, well, we draw our 5 blanks, put 2 together, draw an extra blank up here, 2, 1, 4, 3, 2, 1, multiply everything together, that's going to be 48. And so now our answer is 120 minus 48, which gives us 72. So the number of ways the vowels are never together is the total ways, 120, minus the vowels always together, which gives you the vowels never together. All right, let's try a little bit of a tougher one. How many arrangements of the word Canada are there if the letters C and D are never together? Go ahead and pause the video and give it a try. All right, so the first thing you do is you look at the total. So the total is going to be here 6 letters, so 6 factorial. But there are 3 A's, so we have to divide by 3 factorial. If you just did 6 factorial, you forgot about the repeated letters. So there's only going to be 120 total options. Okay, so how many, though, where C and D are always together? So C and D always together. We can still use the blank method here. So we're going to have 5, 4, 3, 2, 1, 2, 1. It's going to be 240. But then we have to take that and divide by the 3a's, the 3 factorial. So 240 divided by 3 factorial. That's going to give us 40. So now we do the total minus the opposite to get our answer. The total was 120. The opposite question was 40. And that gives us an answer of 80. All right, so let's take some notes on this. This new technique was never together. And the technique for never together uses what we learned last time. Whenever you have a restriction like never together, it's actually easier to think of the opposite question. So what you do is the total minus the opposite, and that gives you your answer. So usually the opposite here will be, instead of never together, the opposite is always together. It allows us to go back to our original formula and shortcut from last lesson and leverage it to solve this new problem. Now here the total, this just means the total number of options with no restrictions. So this is like just a pure 5 factorial, but of course if there are repeated letters, you do have to divide by that repeated letter. So let's do an example over here. Let's say 7 people are going to the movies. So 7 people are going to the movies. And let's say 2 of them are having a fight. They hate each other and they just cannot sit next to one another. So how many different possible seating arrangements are there? If 2 people can't sit together. So pause the video and give it a try. All right, so we have 7 factorial, which is the normal 7 people sitting in a row. That's going to be the total option. Then if we have the people can't sit together, we can think of it as the way they must sit together. This is sort of like you have 2 people who are a couple and they're on a date. They want to sit together. So you get 2, 1, 6, 5, 4, 3, 2, 1. So that's going to be 6 factorial times 2 factorial. And then when we subtract that, 7 factorial minus 6 factorial times 2 factorial, we will get a total of 3,600 options. All right, you can go ahead and add another example to your notes. We'll look at worksheet 6 or 6.5. And then you can write down any things to remember. The main thing you might want to remember is that when doing this, you have to watch out for repeated letters, or other things like that. The total minus opposite method is really handy, but you do have to make sure that you're still following the other rules for the counting. And of course, when you're doing this, the technique works well for things like never together when the opposite is easy to calculate. So you're looking for an opposite question that is easy to do, or at least easier to do than the current question. All right, hopefully you enjoyed this video, and as always, thanks for watching.